Alright, so I'm gonna make a little tutorial on how to draw text sort of similar to a handwriting style, how you might see text grow. Let me just demonstrate this. So this could be used for a number of different effects. I'm showing a solution which uses some vex here. If you know of an easier way to do this, please let me know. I'm going to start off with a font node here, just whatever you want, and then using straight skeleton 2D, lab straight skeleton. This basically gets centerline curves for it, and you do have to tweak this resample size parameter. Let me just make a new one here so I can show the default value. Yeah, so that's a little too much detail for me. So what I do is I raise up the resample value, really pretty fine tune here until you get the right number of stuff showing up. Note that you do get different numbers of primitives resulting depending on your resample size. If you go too low, you're gonna get more primitives. So I've just found this value here of 0.0174. It has basically, it results in, let's see how many primitives, 6 primitives. So there's one for the N, two for the I, 1, 2, 3, yeah, and then one for the C, and then 2 for the E. There's one for the top part of the E and one for the bottom part of the E. I'm gonna get to these sort and reverse nodes a little bit later, but I'm just gonna get into this draw text HDA, which I'm planning on releasing on Orbital, but I'm just making this tutorial first. Before I dig into this code, I just wanted to actually explain the algorithm. So I've made a little I put together a little diagram of it, but let me just kind of explain what we're trying to do. So basically, over time, we're going to use the carve node to only show parts of each of these primitives. And if I just do a carve sort of off the bat without doing any manipulation, you can see that the first U, if I manipulate this, it'll shrink from the front, every primitive at the same time. And if I use the second U, it'll shrink from it'll sort of grow it from the front. But the problem is that every letter or primitive is growing at the same rate. So like, even though this I is less length than the N, it's still growing at the exact same time. So my algorithm, I want it to grow the letters at different speeds depending on their length, which is more of like a handwriting style effect. So basically, we need to over time give different carve values to each letter depending on its length. So we can use this measure node here to measure the length of each primitive. And if you look in the geometry spreadsheet, this adds a perimeter attribute right here. And then I also want to get the total length of the entire thing. So I use an adder promote from primitive to detail with promotion method to sum. I'm changing the new name to max length, and I uncheck delete original. So now if I look at the detail here, I have this max length attribute. And before I dive into this primitive wrangle here, I'm just going to show the algorithm that I've come up with. So we have kind of two different ranges that we're working with. We're working with a timeline range, which has a user-specified start frame and end frame. These are, by the way, parameters on my HDA. Okay, and the current time is somewhere in the middle of that. And looking at that ratio, we're going to get a percentage between 0 and 1. This is like our percentage along the timeline, along our time range that we defined. Okay, now we have a second sort of range, which is length dependent. So on one end of it, we have 0. On the other end of it, we have the total length, which we've extracted from measure. And if we want to get, well, what is the total length that we want to achieve at this particular frame, we can take the total length and multiply that by our time percentage. And so if you think about in the Houdini, like if we're somewhere in the, let me just go back to demonstrate this. If we're somewhere like here, right? So at this point, this node, the N, should have a carve value of 1. And then this I should have something between 0 and 1, and everything after it should have a carve value of 0. So how do we get, and we're using a primitive wrangle in here. So all these primitives or letters are getting processed at the same time. So we basically need to produce all those values, a 0 for the n, a number between 0 and 1 for this I, and then a number of 0 for the rest of them. We need to do that all in this single primitive wrangle. Okay, so let's look back at our diagram. So we have a couple different variables here that I'm defining. We already have our target length, the length we want to achieve at this current frame, and we have an accumulated length. This is the sum length of all the primitives with a lower number. And I'm using primitive numbers to sort of determine the order that these letters get drawn. And then we have the current primitive max length, which is at this length, the current primitive will already be completely drawn. So that's calculated by the accumulated length plus the length of the current primitive. And now I need to get a carve value. So it's pretty simple at this point. I remap the target length in the middle from this range defined by these two variables into the range of 0 to 1. And so if the target length is greater than the accumulated length of a particular primitive, if it's less than that, if the target length is less than this length, we're going to always get a 0. Which means that it wouldn't get drawn at all. And if it's greater than this current prim max length, it's going to end up as a 1. So, but anything in between will be between 0 and 1. So let me just get into this vex here. So we first get our start frame from the parameters. We get our frame percentage. It's basically the current frame over the end frame, but we offset it by the start frame. And then to get our accumulated length, we just do a loop. Starting at I, and then I is 0, I is less than the current prim number, and I is increasing, and then we just look up the primitive, the perimeter attribute, and we add that to our accumulated length variable here. We're just kind of building up the same variables. These 4 variables, we're just building these up. The next one is the target length, which, like I said, is the frame percentage multiplied by our max length, which is living on the detail. And our current prim max length is the accumulated length plus the current perimeter. And so that's these two values here. And now we just do our fit function, like I mentioned. So we fit from the target length to the so we fit our target length between the original range is accumulated length to current prim's max length, and we remap that from 0 to 1. And then we have a for each prim loop right here with a carve in it, and then in this second U, I'm just using a vex expression to read that carve primitive attribute here. And then this actually just gives us what we need. And if I go back and I can change some of these parameters to say I want to start at 50 and end at 200. So now you can see it's nothing until 50, and then it grows until 200. Now it's done. So that does work. And so the only other thing, I'm going to actually bring this back from around 0 to 120, maybe limit my frame range here. The only other thing is that you want to maybe be able to control some stuff about how this is drawn. So maybe make it look more natural. So for example, for me, I might prefer to draw my eye from the bottom up. I also want like this E, like the second part of the E, to, instead of going this way, I want it to go the other way. I was like up and then back. So you can just use a reverse node for that. You basically just select these primitives that you want to change the order that they're drawn in. And then, let me see here. Sorry, not this sort. What's going on? Okay. And now, yeah, you can see that I've changed the way that this I is drawn and the way that this E is drawn here. Okay, so, and then the other thing is you might want to change which order the primitives are growing in. So I'll just give one example. I think in this one here, yeah, I'm only looking at this E. So I wanted, so, okay. So the E is growing first the bottom one, then the top one. because remember there's two primitives that make up this E, so the bottom one and the top one. And I actually wanted to change it so that it drew the top one first, because this is maybe how I draw my E's or something. And to do that, you just select the two primitives in a sort node in the group, and then you change the primitive sort to reverse, and that'll just reverse their primitive numbers, so that they get fed into the algorithm with the correct order. And that's actually pretty much it for this. Yeah, pretty simple effect, but I'm planning on like kind of using this as a source for some simulation stuff, like draw some fluid in the shape of these letters, like as they're being drawn like this. That's what the context that I created this in, for sure. And I will add the link to the OR bolt to the description once I finish uploading that. Thanks.